Okay, a little behind. My class just before that, they have a test next week, so we're starting in review. A lot of questions today, maybe more tomorrow or next week or Tuesday. We have our exam Tuesday, right? Thursday. Today is Tuesday. So I don't even know what day it is anymore. Okay, today's Tuesday. Thursday we have our exam. We're not having it today. Today we are looking over the review, which is in Canvas under Exam 1. So there's review solutions, which I encourage you to take a look at those. They're pretty detailed. They're in color coding. So, but I also encourage you to kind of do the review first. However, things work out. Sometimes you need to look at the solution to figure out what's going on. But if you do that, what you're going to want to do is probably go find some similar problems to work like those. I told you, I've seen the review, right? I've seen the test. It's, now I saw the other test, and now that's going to confuse me. But there is there's 12 multiple choice.
I think you put it in the announcement.
Thank you. I couldn't remember what I've done anymore. So, in fact, I think I did it here, right? Maybe? Let's see. Oh, study solutions video. Is that? I haven't even looked. Did I put in a study solutions video? Oh, that's right. I even made a video of it all. But it's not. I haven't worked through each of the solutions yet. But I just tell you basically how to prepare to study. So yes, here's just the exam review. We're going to pull that up, and we'll take a look. We'll give an overview of kind of what you need to be able to do, and then we can take questions on anything that you might have questions on. So let's go to the announcement, since I put it here, and I can't remember.
Preparation for our exam is
In-
that you have detailed it.
Good. Oh, thank you. Thank you. I'm glad somebody looks at them. Someone remembers what I did. So that's what I was thinking. I thought there was 12, but it's always best that 12 multiple choice. So for the multiple choice, we give you all the answers. So for 12 questions, you have all the answers. The only problem is for every right answer, there's 3 or 4 wrong answers. Sometimes there's 5. So some of them go through like F. Most of them go only to D. There's a couple of them that go to E. So as far as choices, circle the right answer. Well, I put in a little thing where you can actually you sort of color it in. It's not a Scantron, so it doesn't have to be pencil. It could be pencil or pen, but just indicate which one you choose. If you change your answer, just make sure that's clear which one is your final answer. If you need to write it out or whatever, but we'll do that. So 12 of them, choose the correct answer. Okay, so you're going to have a question. You're going to have the questions. You won't have to worry about whether it needs to be rounded or not. You just have to choose the right answer, right? And there will be one right answer. I worked through it. It's all there. Then there are, let's see, 2 short answer questions. And the short answers, you don't have to show work. Again, if you do, it's helpful. Sometimes one of the ones that does ask for what's your reasoning. So, your work could be your reasoning, I guess, but to provide that. But the 2 short answers there's just a question and then a couple lines to provide the answer. And then there are how many? There's 3, what they call the free response answer. I call them like essay answers. They're just a question. They want you to show all the work, get the right answer. Here's what, I get the question, how much work do I need to show, or what kind of work do I need to show? Focus first on getting the right answer. If you can box that in for me, and then provide work that shows how you got there. I'm not going to say, oh, you didn't show this or that, but show me that you understand how to get there, that you didn't just pull the answer out of a hat or something, but something, okay, that you understand the process. And if it's reasonable, go there. If it's, and I think some of you have had calculus. I guess if you use a calculus tech, I don't like grading on methods, but so if you can get to the right answer, show some work or something that shows that you got there. That's the idea behind that. So part of this is, we're learning how to do the right calculations and get there, but we're also learning to communicate with our colleagues. If you're engineers, you've got to communicate. You can't just say, well, the answer is 5. They want to know why you say it's 5 because they've got to check it out. And even great engineers and scientists have made messes, which there was a telescope they sent up. It was an international project, and it all came down to it messed up because one was using inches and one was using centimeters, or they didn't have the right units, and so things blew up. And so they didn't communicate. It wasn't that they didn't know what they were doing or the technical side. They didn't communicate. So that's what we do. Again, calculators, graphing calculators, department says no CAS, which is computer algebra systems. That does it for you. You can talk to me about that if you have any questions. And again, on the multiple choice, you don't have to show work, but if you do and you get an incorrect, you choose one of the incorrect responses, because some of those incorrect ones are very tempting and could be there. If you've got some work that shows that you did the right step, but you made the calculation error that got you to the wrong answer, I can give some partial credit. But if you just circle a wrong answer with no supporting work, that's 0. Okay, so nothing to do. But if you got some supporting work that shows, we can talk about that. Okay, so it's to your benefit to show that. If you want, I can't remember. I've got it out at the printer, so that I can have it by Thursday. I can't remember how much room, but if you're a person who likes to have more room, you can bring scratch paper and have it on the scratch paper. All I ask is that clearly label which question it's for, so when we have a discussion about it, we can refer back to some people, their scratch paper, like mine, it's all over the place, and like, oh, that's the place I want it. But so it has to be, again, communication. Okay, so any questions in general about the exam? Short answer, it's a good question. I'd never seen one like this. And so short answer is just you don't have to show your work. And it really is, it's like 1 or 2 sentences. You do an explanation, or you could say that, well, it's 5 seconds until this happens, bye, Bob. So it's kind of more, not quite fill in the blank, but maybe 1 or 2 sentences, and you can explain away. The free response is that it's more like a homework question, but they want you to show the work, and then you don't necessarily have to have the answer in the form, the complete sentence or something, but you would box in the answer to the solution somehow. Does that help? Okay. Yeah. When I first saw the instructions, I said, what's the difference between short answer and free? I thought they were the same. And then I saw the exam, and it's kind of clear, because they'll just, the 2 free response, they've got actually lines, I think 3 sets of lines where you just kind of fill in the answer. But the free response, it's all open paper to show your work. All right. And then I put links to these, and that's really all we have. And I've compared the exam. It's really all we need. Yes?
Are there going to be a lot of questions that require us to graph on a graphing calculator?
There will be some. I don't have because I look at some, I don't, but yes, it's something we need you to. Now, could you do it without? Potentially. Again, some people are pretty good at doing it. I would highly recommend having a graphing calculator and using it. And part of what I will do is, I'm doing this for my other class. I'll make somewhat of a brief video specifically for this class to show how to use the graphing calculator. A couple things like finding zeros, and it's very helpful. We can use it. We didn't use it earlier to find the zeros, right? We used those rule, Descartes sign and the rational thing. You could do it without, but I think I did show one. Didn't I do one? Maybe it's in the video, where I think I showed how using the graphing calculator could be helpful. But I'll go back, and when I'm in a better place and don't have all these other classes in my head, I'll make one that will show how using the graphing calculator can be useful on this particular exam. And I'll try to make it like a shorter one, 15, 20 minutes, where it just kind of shows a few techniques using the graphing calculator that could be helpful. But I would say having one and being able to use it appropriately would be helpful. We don't have you produce a graph. However, that's also something you could show as your work. So if you do graph something and show it, sometimes, do a quick graph. It doesn't have to be all to scale and everything, but sometimes I can see from the shape, I can pick up, oh, you forgot a negative and it's going the wrong direction. You've got sort of the right shape, and I can see where it came from. It's showing work, and I can give some partial that at least you had the right thing in there, but you had a plus instead of a minus or something. Sometimes that's helpful. So, just a little box with here's the shape here's the sort of general shape. I know I'm not really a good drawer. Some of you are much better than me, but some kind of thing that can count as partial, can help for partial credit. Let's see if I go here. Yeah. So let me just give a few minutes sort of a general overview of what's going to be on here. And it really is I've worked with this coordinator because I do the 170. So we kind of spent a summer working together on the two classes, and she says she has a little bit different, but the 170 and 171 are very similar. What you get in the 171 is a little bit more algebraic manipulation stuff. So we'll talk about that. And there's a couple of concepts in here, but let me just kind of give a 15 or 20 minute overview of all the things that you should be looking at. Bless you. So, this first one, and again, there's 16 questions here. There's 17 questions, I think, if I added them up right, on the exam. So the review is very, it's very focused on what you need. Some reviews I've seen will be like 50 questions, do this all, and obviously not everything's going to be on the exam. You can really count that everything that's on here is going to be on the exam. Okay, so so this review, know it all, or at least know enough and know the thing that you don't know. There'll probably be a question about it, but you'll be okay. So, being able to see a graph, come up with its domain and range. And, if given a y value, be able to say all the x values that do there. Again, there's solutions to these. If given a function in sort of the symbolic form, an expression, be able to find the domain. And remember, that is when we're talking domain, there's two problems really we're trying to assess that assume that every function we have generally is going to go from negative infinity to infinity, but there's two problems when we get to domain. And what are those two problems? Division by 0 is one problem because it can't be done, or sort of, well, it can be, but it's not a real number, it's infinity. But this one and that one relates to something like this. We're looking, is there a place where the denominator becomes 0? Okay, so that's one thing we're looking for, the domain. Second thing is if we have a square root, if it's negative inside of a square root, so that would be this thing, then that's an imaginary number. So it can be done, but it's an imaginary number, so we say that it's not in its domain because it doesn't produce a real value, a real number. Okay, so those are the only two things. So if you see the question about domain, we're looking for those two things. We take those problems out of the domain and we're good. If we don't have either one of those, the domain is everything. So negative infinity to infinity. So that's where I always start, is I make that assumption, and then I look, do I have one of these two problems? Okay, yeah, I do. So let me take those problems out, and that's what the domain will be. Okay. And again, we're just doing a high-level overview, but as we do this, we can come back, we can work any of these. Oops. What do I need to do? I need to go here. We have a function, and we're asked where is it increasing, where is it decreasing, and where is it potentially constant. So something like this, that's where I would just graph it. In looking at the graph of the function, we hopefully will be able to see these things. Again, you could potentially do it other ways, but graphing it is going to be the quickest. Maximum minimum points. Again, this is not a calculus class, so we don't have, I mean, you could take a derivative and find it, but that's not what's expected here. Here, expected to graph it and then find those maximum minimums using the graphing calculator. Again, we could, especially with a cubic, if we could find one root, we could also turn it into a quadratic, and then we've got the quadratic formula, we've got vertexes and stuff, but this one is really designed, graph it, and find everything with your graphing calculator. So we can work this one. Again, I would show on my little calculator how to find the maximum, how to find a minimum. They're basically the same. How to find zeros using your graphing calculator, be able to know those things, okay? Now these ones, I'll come back to this and do it because definitely we'll want to know how to do these. And this is the difference quotient. So this is the one that gets us into calculus. Remember, it's really just a slope formula. So we'll go over one of these because they're a little challenging, and the one on there is no more challenging, but it's there. Be able to evaluate a piecewise function. Now this one also asks you to sketch it. We're not going to have you sketch any ones on the exam, but be able to evaluate, so we'll take a look at that. But know about piecewise functions, and remember that you kind of have to look at the domain first. So if x is less than -3, we're using this piece and only this piece. If x is greater than or equal to -3, then we use the second piece. So it's that's all the piecewise function is it's, I think of it as two separate functions, and I've got this, but they're somehow connected, is really what it is. So there's, but think of it as the two pieces are two different ones. Even, odd, or neither. Again, you could do this with a graphing calculator, look for the symmetries, but the way and a lot of textbooks won't tell you this. Come on. I'll come down here. Even function means that all exponents will be even. And we kind of talked about the constants, right? That this 7 is really like -7 x to the 0 power. Is 0 even? Yes, it is. It's not. So if I've got a constant in with odd exponents, then it's neither, because it's got a mix. Okay, but here this is even, and basically this is even, so I can say, yeah, that's even. This one, I've got an odd. This one, first power is odd, but what's this 5? This is x to the 0. I've got even and odd, so that's a neither, right? So it's not going to have the symmetry of an odd exponent. Had it not had this -5, it would have two odd exponents and it would be odd. Okay, so just notice that that's part of what's being tested here. And this one's neither, because we were only dealing with integer value for polynomials. It doesn't really, or does it apply? No, we could do this one. Again, that's like x to the 1/3. You could graph this one. They threw me a curveball here. It graphs something like this. It's like a cubed function, but on its side. And remember the other definition of odd function is it has origin, symmetry, and what I describe that as being like, if you think of this as a spinner and you spin it 180 degrees, it lands on itself. Yes. Yeah, that would be even. And odd is, yeah, so there's, I'll go back and look it up because I don't use that one much. Sure. But again, you can always graph it. So graphically, even symmetry is going to be symmetric about the y-axis. And odd symmetry is going to be symmetric about the origin, which means, what that means is if you go through the origin, and again, I don't, the way I explain it is, think of this as a spinner. If you spin it 180 degrees, it would land on itself. So that's the type of origin. But we can see that the positive x's go to positive. Over here, the negative x's go to negative. And you get the same sort of thing. And again, something like this for odd. So this is even here. If you take a negative x and you square it, you still get the same thing. So that's why this is the definition for even, and the odd is the opposite. And it's kind of saying, yeah, f of x here gives us that, but if I put in a negative x, I think it's I think I just need a negative here. Yeah. I think that's the one. So if I put in a negative x, I get the opposite. So that'll work too. But I also highly recommend using the tutoring center. Okay, so especially the one in Wienerger, or not Wienerger, that's Oregon State, Wexler. And at Oregon State, Wienerger was the math center. This is Wexler, so I get them. No, they both start with W. So it's been 20 years since I was at Oregon State, but I still get them mixed up. Okay, so it's that, but know about even, odd, or neither. Again, there's going to be a question like that. Let's clear that out. Know about transformations, right? Shifting left and right, and one of the key parts is anything that happens inside the function, which is usually inside the parentheses, that's going to affect x values, which is horizontal. And so that's sort of a left-right effect. And then also remember, it's always opposite. I don't know if it's 1p or 2p's. But whatever's happening in there will do the opposite of what you think. So if I've got, so x minus 3, sort of inside the function, instead of moving it in the negative direction, it's moving it 3 to the positive direction. So just think it's sort of the opposite. Whereas if I'm outside the function, so here's whatever the function is, if we're out here, if I subtract 3, then it does exactly what I think. It's going to go down 3. So this is outside the function, and that's going to have a vertical effect, and it's going to be sort of what your gut feeling would tell you. Okay, a plus will go up, a minus will go down. Okay, And we've got stretches, and if I do something like f of negative x, what is the negative going to do? It's going to be a reflection. But notice, since it's on the inside, it's reflecting the x's, which actually will be a reflection over the y. And then if I do it on the outside, that's going to change the y values, so that will actually reflect over the x. Okay, so transformations, be able to work through those. And again, once you get to these, if you look at it and you're able to do it right away, you know it, okay, that's fine. But if you look, the thing is, it's harder as you get to the one and you're struggling a little bit with it. You don't want to look at another one, but you need to. You need to go find one that's similar to it, and you need to, those are the ones you really need to understand. However, I also encourage you to take the ones you do understand, get stronger in them, but you need to, I always want to skip those ones I don't really understand, but those are the ones you're going to want to try to work to understand. And a lot of times it'll open up everything else for you. So be able to, given a reflection, be able to come up with the formula. Given a formula, be able to say what were the transformations. Okay. Be able to do function calculations, so adding two functions, subtracting two functions, multiplying two functions, dividing two functions, okay, and composite of two functions, and usually that's the harder one. Remember, this is f, composite g is f of g of x, so you've got to get the order correct. And you're going to take the g function, plug it into the f function. So that's a little different than all the other combinations we did. So this is, this we just take the two and subtract them, take the two and divide them. But these compositions is you plug one in, go into one function first, and then you plug that one into the other. Okay, so be able to do the compositions. Inverse functions, and again, we went over this fairly recently, but remember, inverse is you're just switching the x and the y. Yes. Not if it just is asking for the division. So this one we're not. We did do some where we did long division, and so if it does say divide these two, and it'll be kind of obvious. There is the use of the synthetic division that we learned, but this one, if it just says find, here's f, here's g, here's f over g, most of the time it's just write it as a fraction. We don't have to do too much. Now, again, if it's in the multiple choice part, you have to be able to match up the right answer. So it could be that it is factorable and they factored it, but a lot of times you'll be able to see that from the answers that are given. But for me, if it's a free response one, I don't think they give a little bit more complicated, but I would just accept the fraction written out. Inverse, and again, really remember there was some steps we went through, but we would rewrite this as y equals x over 2x minus 3, and then you switch the x's and y's, so this is x equals y over 2y minus 3, and then we solve it for y. And again, we've done some. You can look back through the videos, and we can do this maybe if we still have questions on it. But for both of them, that's how we find the inverse. Quadratic formulas. So remember, we came up with the quadratic formula, and notes are not allowed on the test. We don't provide the quadratic formula, so you have to know it. Minus b plus or minus b squared minus 4ac all over 2a. And one of the things I do is if you have to do a problem with the quadratic form, always write it down. That'll help you remember it. Even after teaching all these years, I'll forget, so I have to look at it again. I'll mix up some. Anyway, it's there. Remember, for the vertex, there was this part, the x-coordinate of the vertex is this minus b over 2a. And then because this is the root, so you're taking that vertex is in the middle, you're adding and subtracting this square root thing over 2a. So that's going to give you your roots, your zeros, but the vertex is halfway between. And then the y value, you take that, whatever this is, the y value comes from plugging that back into the quadratic function. Okay, so that's the y coordinate. This will give us x-intercepts, the quadratic formula. The axis of symmetry comes from the vertex, the x-coordinate of the vertex, whatever that is, x equals that number, is also the axis of symmetry. It's a vertical line. And then the y, remember the y-intercept will be whatever the constant number is, because you plug in 0 for x. So if there's any constant number, if there's not a constant number, what is the y-intercept? 0, because there's always a plus 0. Okay. Getting pretty close here. Be able to work through this one. We've done similar ones, but and again, this one, a graphing calculator is helpful because you can be able to see the path of, or sort of the flight, by being able to look at this. And again, there's questions like, when does it reach its maximum height? If you do a graphing calculator, pretty good. You could also use the vertex formula. What is the maximum height? Again, calculator will get that for you. And for it to reach the ground, that's an x-intercept. You could use the quadratic formula, or you could use a graphing calculator and find it that way. Round to the nearest tenth. So yeah, be able to do those. Remember the multiplicity thing. So we may need to factor these a little bit, but we could also graph them. So remember, there was 3 types of zeros. So if I had just like, if x minus 3 was a factor, what that looks like at positive 3 is where I'm going to get a 0, right? And it'll be a type of 0 where it goes straight through the x-axis. If it's a multiplicity of 2, that means it's got an exponent of 2, multiplicity of 2. And what happens there is it's also going to, negative 3 is a 0, but think of it, it's a double 0, so it will, let me do it this way, it will kiss the axis, and it might be that way or it might be the other way, but it's just it's not actually going to go through. It comes up, and that's what a double looks like. And then we had one other kind that would be like x minus 3 to the 3rd power, a triple multiplicity, or multiplicity of 3. And what happens again, at 3 it's going to cross, positive 3 it's going to cross, but it does this sort of thing where it kind of does, it takes its time and sort of meanders. And you would see that on the graph. So these ones, if you didn't want to factor, you could just graph it, and you would see at the places where the x is, what behavior does it have. If it has this behavior, then I would say it has a multiplicity of 3. Multiplicity of 3, that's kind of a strange word, isn't it? Multiplicity of 2 and a multiplicity of 1. Okay, so either identify them graphically or by the exponents. But the exponents you may need to factor them. If it's given to you in factored form, you got it, so they might do that too. And incidentally, in my review of the exam itself, you should find it no harder and probably easier than the homework is, or even the review. If you go through the review, they took the questions they're using are primarily to assess if you understand. Find all the zeros. Again, this is a good one. You can use all the techniques we've gone over. What is it? The rational zeros function or idea. So you could use P and Q. But again, if you use your graphing calculator, you'll find one of the zeros. You don't have to do all those searches. We know there's a method to do it, but the fastest way, graph it, find that zero, and say it's x minus 3 or something, and then use synthetic division to find the others. And I think I did one. But you'll also see that there could be imaginary zeros. And I think this one is one that I think it's got one real and then maybe two imaginary. And then you would use the quadratic formula for that. So you would use that to find one, you get it down to a quadratic, and then you could use the quadratic formula. Okay. Because it wants all the zeros, even the imaginaries. There is one like this, similar, where they give you some details and they say find the function. So we'll take a look at that in just a moment. I want to kind of go through it, but I'll come back to this one because I've had a few questions. And these are some, there are questions about what happens in the long run. We'll talk about this one as well. And remember, that's looking for the horizontal asymptote. That's all it is. Okay, so that's our explanation. What's happening in the long run? Why? Well, that's the horizontal asymptote. And again, we'll go there. And then we could have asymptotes. So that's when we have division by zero. But remember, we could also have just holes. And remember, I got mixed up on one. I thought we got two asymptotes, but when I graph it, one of the asymptotes wasn't there. It was actually a hole. So when you go to find your asymptotes, you just look at where the denominator is zero. But if there's a similar factor in the numerator, that will cause it not to be an asymptote, but a hole at the graph. And again, those show up easier when you graph it. So if you use a mixture of the methods, the algebra plus graphing, it makes it pretty straightforward. Okay, and again, that's all the questions we have. There's some multiple parts. There's some answers here, and then there's another document where the coordinator went through and actually worked through each of these. So I highly recommend taking a look at those. Which was the one I said? We did that one. Kind of did that one. Let me do this one, and then I'll just see if there's any other questions, and we can take a look. But third degree polynomial, so that we know it's x to the third is the biggest. We're given some zeros, and we're given 1 point when x is 0. So this is the point 0, 17. That's the y-intercept. And so we could assume we're going to get something there. But if we know something's a 0, what do we know about it? Well, we know when x equals negative 2/3, that's y is going to be 0, right? So what I always do is once I set it up, if I added 2/3 to both sides, what that's going to give us is that x plus 2/3 equals 0. That's the definition of 0. It's giving us one of the factors. Okay, so I know a third degree is going to be x plus 2/3. What about this one here? This is also a 0, right? So to make this, I would subtract it. So x minus 1 minus 4i equals 0. The negative distributes through. That's x minus 1 plus 4i equals 0. So this is one of the zeros, one of the factors. And we had a theorem. If I have a complex root, such as this, what do I know about another complex? Because they come in pairs, right? So there's another one, and what is the other one? What's that? It's 1 plus 4i, right? Because they come in pairs, so the conjugate 1 plus 4i also has to be a 0. So that's going to basically be the same as this, x minus 1 minus 4i. And again, you could go through the steps and see that that's, when I subtract it over, it would have been plus, and so that would become minus. So we know this is it, and then so we know that's the function. But remember, in every case, there could be some constant out here. We know the zeros, but when you take a 0 times a number, what do you get? You still get 0, right? So there could be this number, and the way we go about finding what that number is we plug in this value that they gave us. We know when x is 0, y has to be 17. So we get 17 equals a times all this stuff, with 0 plugged in for x. And then, oops, sorry. And again, this has all been worked out. 2/3. And 0 minus 1 plus 4i. We can multiply those out, solve for a, and we'll be there. And remember, that's the nice thing about the conjugate, the complex conjugates, because the complex number will actually disappear. It will actually disappear. We'll find a value for a, and then we have our function. And again, we can take a look at that being worked out. But be able to work these types of problems, and I think those were the ones I've received at least the most questions through email and other things. These zeros tell you have to kind of solve them for 0. That gives you the factors, multiply them, and then there's always this unknown, because the zeros don't tell us what that number could be that's multiplying by it, but the fact that they gave us 1 point will allow us to find what that is. It would allow us to solve for it. Okay. Got about half an hour. Questions? Anything you'd like to see?
This wasn't on the hard copy, but on the Pearson exam overview, can you go over, I think it was 18 and 19?
Sure, sure. And thanks for reminding me. The other thing is look at that Pearson review. That's part of the homework. The homework well, when I get in, I'll figure out. I extended it all, so you'll definitely through the exam, and I think maybe through the weekend. We'll see. I can't remember when but I did extend everything so that you could focus on these. At this time, since the exam's on Thursday, probably if you still have homework, let me check real quick here. If I go to the assignment manager, I think this gives me the due dates. I moved them to 8/17, which I believe is Sunday. So they are open through the weekend. So if you still have homework to do and you're worried about those points, don't stress too much, worry about the test right now, which is look at the review, and the Pearson review is a good one to go through. But this, created by the coordinator, I said, if you know all of that, you'll be good. Yes. I would look at both, and I would first work through the one in Canvas, the printed one, those 16 questions, know those, come back to the Pearson review to work similar type problems. Okay, 18 and 19. Okay, so we're going to take a look here. So we see the exam 1 review, and again, they're all open till Sunday. Let me go to preview. And again, I know there's the other thing is, make sure you get enough sleep the night before. Don't, pulling on the all-nighter maybe gets you through things, but it's also best to get some sleep in there. Let's look up at 18. It's hard to see, right? Okay, something like this, huh? And so this is a good follow-up. Again, there's one like this in the review, but here's another one to do some practice with. And I don't know, do you guys get exactly these same questions? Are you?
I think they keep changing.
Yeah, so you could do it multiple times. What I would do on the exam, and even this one, is I would graph this first because it's going to give us a place to start. We're going to need a starting. If we knew a zero, and again, this is the exam question is very similar. Like it'll say it the same way. In fact, it almost looks like using a graphing utility. So I would come through and go to my graphing calculator. Let's clear that out. We're going to put in x to the 4th minus 8x raised to the 3rd, and you have to arrow down 15x squared, and that's plus and then what is plus 58x and then plus 34. I'm going to go to I'll first go to Zoom standard, just so that it's got the window, I know what it's fitting, and I see it's crossing right there. Okay, I could assume it's -1, but I could also use the tools, or I could go to the second table, and I see when y is negative, or when x is -1, y is 0. So I've got 1, 0. So that gives me a starting place. X equals -1 is a 0, right? Or x plus 1 equals 0. Okay, so either way of looking at it. Remember, that's why we always took the opposite sign. So when we do synthetic division, we're going to divide by -1. We rewrite this with all the coefficients. -8 plus 15 plus 58 plus 34. I think I may have worked this one. But I don't know if I recorded it. I know I went through. Anyway, synthetic division. 1 comes down. -1 times -1 is +1. -8 plus 1 is -7. -1 times -7 is +7. Add these together, that gives us 22. -1 times 22 is -22. did I? Oh, thank you, thank you. I knew, yeah, it's going, there's something wrong here. -1 times +1 is -1, so that's, yeah, so these are going to change. I was seeing I wasn't coming up with another 0, so thank you. So that's -1. This is -9. -1 times -9 is +9. That is 24, +24. This is going to be -24. 8 minus 4. Did I get that right? Okay. 34. I get -34. I get a 0. So that's good. So what I found is that this is another 0. And so what is that? So it's this was x to the 4th. This is going to be x to the 3rd. Oops. Wait a minute. 3rd. Oh, why did I go with the 4th? I have to count down. 3, 2, 1, plus 34. Okay. Now we need to do the same thing, but hopefully we saw that graph. We saw the way that when we look at the graph, what kind of a 0 is this at -1? What's its multiplicity? 2. And so what that tells us is there's basically 2 zeros there, that we have this as a factor, so that we can use -1 again. So we would take this one, divide it by -1. We end up with a quadratic. And what I need to do, I remember working this one. If we zoom out a little bit, and here's another thing you can do is here there's something called zoom fit. Sometimes that gives you a good fit. We came out a bit. It's maybe a little too far out. I'm going to make an adjustment. Let me make my, I think I did this, maybe make it -200. And I think maybe this is going up to 18,000. That maybe 500 will be enough. And when I look at that graph, here's a real 0. I can see there's going to be some imaginary zeros because this is where it could have crossed again, but it didn't. So those are imaginary zeros. I'm going to get 2 imaginary zeros. So you divide again, you get a quadratic, and then you use the quadratic formula. And in the quadratic formula, you'll get imaginary answers. Okay? Good. Is that good? So go through that process. Yeah. And I think '19. Again, you could graph it, which I highly recommend, but also you could probably see this, the denominator is going to factor. 6 times 1 is 7, so it gives us an x minus 1, x minus 6, right? Because that gives us a +6, but a -7 in the middle. So the asymptotes are going to look like they could be x equals +1 and x equals +6. But we see an x minus 1 here and an x minus 1 there. So hopefully we can see that x minus 1 equals 0. Add 1 to both sides gives us that x equals 1. That is a whole, not an asymptote. So we would say select the correct choice. Okay, yeah, so we need B, vertical asymptote at x equals 6, right? X minus 6 equals 0, add 6 to both sides, and then you get a whole at x equals 1. Do it with the factoring, or you could graph it. Let me show you one technique for graphing if you have the TI-84. So I'm going to go back to the y equals. Let's clear this out. When you're going to put in a fraction, if you go to alpha, and then this is going to activate the F1 action, notice you can actually get a template that's going to be a numerator over denominator. The reason I do this is I see a lot of people when they graph it, they put it in, but they don't put the parentheses right, and it's not actually, you get something different. So I'm just going to hit enter, and notice I get a template now. I can just enter this as x minus 1. And had I did x minus 1 divided by this other thing, only the middle is getting divided if I don't put parentheses. But this one, if I use this, it looks like what I see, right? X squared, and I don't have to put in parentheses or worry about anything else. And then plus 6. And then I'm going to zoom standard again, zoom number 6, gives me this fit. And I can see, yeah, there at positive 6, there is a asymptote. But then at positive 1, it's no asymptote. So this kind of catches me. But I do have a 0 there, and how do I know? I go to the table, and at positive 1, I see an error. But I saw that, so that's what a hole looks like, right? You can't really see it on the graph, but it's saying, hey, there's an error there. It can't really find it. And then also at 6, we've got an error. The x equals 6 is a asymptote. X equals 1 is a hole. So be able to know the difference between those two things. And again, your graphing calculator is going to be something that can help you with this. Other questions? What's the best way to prepare for the exam?
Hard copy.
Work through the hard copy, Pearson as a backup. If you don't get through it, but if you've only got time to get one thing, know that the hard copy really well. And then looking at it, work similar type problems. If there's a problem that isn't like it, it's not hard, but go through that review. But that's indicating all the things you need to know how to do. Yes. Number what? Number 4. Back here. Oh, thank you. It reminded me. I want to go back to this one. We'll focus on this one. So the difference quotient, remember, it's f of x plus h minus f of x over h. So that's our difference quotient. And remember, it comes from this. It's really coming from the slope formula, because if you this would be x plus h minus x, and so the x's cancel out. Okay, so it's really the difference of the y's. So we have f of x right here. What I like to do is right underneath it, let's find out what is f of x plus h. Okay, so we're going to find that part, and then we're going to subtract the 2. Okay, so f of x plus h is going to be 3 x plus h squared minus 5 x plus h plus 2. So that's a composition. We're putting we're putting x plus h in. We need to, x plus h squared is not just x squared plus h squared, right? You FOIL it out, you get a middle term. So this is usually the biggest mistake, or the most common mistake I see. is it doesn't get FOILed out. You get x times x, x squared, x times h, so that's hx, h times x, hx, and then h times h, h squared. So we're going to get 3 x squared. Hx plus hx is 2hx, and then plus h squared. I'm going to go ahead and distribute this, minus 5x minus 5h, and then plus 2. And actually, what I'm going to do is I'm going to distribute this 3 through, just because I don't want to have to rewrite everything. So that becomes 3x, 3 times 2 is 6. Go ahead and erase these while I'm here. And then 3 goes in here as well, 3h squared. Now I just need to subtract f of x. So I'm going to subtract the whole original function. And remember that negative has to distribute through. So what I do is, while I'm doing this, the first term is positive, so that's going to be negative 3x squared. The second term is negative, but a negative times a negative will make it positive. And then I've got a positive 2, which becomes a negative 2. Okay, so I've got f of x plus h minus f of x, all divided by h. And if you've done this correctly, what you'll find is that these second parts over here will cancel with something here. They will all cancel. That's the way it works. So negative 3x squared, positive 3x squared. Positive 5x squared, negative 5x squared. Negative 2, positive 2. You will be left with only terms that all have an h. Okay, you'll have an h there. So we go ahead and write what's left. We have 6hx plus 3h squared minus 5h, all divided by h. See, did I get everything? I did. There's one h, so you could either factor out an h and then cancel with the denominator, or just think that this h is going to divide into each of these. It's kind of the way I like to do it. So this h divides into here. This term, this becomes h to the first, and this h. So I divided each of the terms by h, right? So my final answer is going to be 6x plus 3h minus 5. Okay. And in calculus, you'll see what we just did is what's called getting the derivative. So that's sort of the first step you'll do. You'll do that early on, probably during the first week. We come in, we pretty much start off with this. Or maybe we start off with limits, and then we get to this, and we take the limit of each. Because one of the two ways. Okay? Did that help? Yeah. All right. Only got 5 minutes left. We good? Again, basically, if you want to, again, work through things, yes. What's that? It's helpful. It's actually, sure. So let me remove this. Some ways it's a little easier. So 5x, so g of x, so then we need g of x plus h, which is going to be 5 over x plus h. Okay, so this one, again, the difference quotient, f of x plus h minus f of x over h. So we're going to have 5x plus h minus 5 over x divided by h. And the way to approach this, we could get a common denominator, but typically what we'll do is we will multiply the top and bottom by the common denominator. Which is x plus h times x. Right? Because that's just 1, right? When we something divided by itself. When we distribute and multiply here, what happens is the x plus h cancels, because that's in the numerator. So what we're left with is 5x. When we multiply it here, the x cancels with the x here, and we're left with minus 5x plus h. In the denominator, we now have h, x plus h times x. We can distribute in the numerator. I'm running out of space here, but you get 5. Let me do it here. Negative 5 times x is going to give us negative 5x. And then negative 5 times h gives us negative 5h. Negative 5x minus this becomes 0. So remember, there's always that canceling. Negative 5h is left there. This h can cancel with this h, so notice I didn't multiply it out yet. And so what we're left with is negative 5 x plus h times x. So you could distribute the x, you'll get x squared plus hx. That's the final answer. But these ones, again, they're challenging. The thing is you have to know to multiply by the common denominator. And that will cancel out the denominator so that you don't have a fraction in a fraction. Okay. See you Thursday. We'll get started right away on the exam.